Now we are going to discuss about divergence, curl and gradient. These topics we record the one operator that is called del operator or Napla operator. The del operator is the vector differential operator. The del operator in different coordinates. Already you are familiar about these various coordinates. The coordinates are Cartesian, cylinder and spherical. In Cartesian coordinate, the del is dou by dou x into ax plus dou by dou y into ay plus dou by dou z into az. In cylindrical coordinate, the del is dou by dou rho into a rho plus 1 by rho into dou by dou pi into a pi plus dou by dou z into az. In spherical coordinate, del equal to dou by dou r into ar plus 1 by r into dou by dou theta into a theta plus 1 by r into sin theta into dou by dou pi into a pi. And the unit of this del is 1 by meter or meter power minus 1. Now divergence. The divergence of a vector A at a given point P is the outward flux per unit volume as the volume sinks about point P. Divergence of A equal to del dot A equal to limit del V tends to 0 closed surface integral A into ds divided by del V. That is, A is the vector representing the flux density. The total flux through the closed surface S enclosing the volume delta V is given by closed surface integral A into ds. The divergence in different coordinates. These are the formulas. For Cartesian coordinate, del dot A equal to dou by dou x into ax plus dou by dou y into ay plus dou by dou z into az. In cylindrical coordinates, del dot A equal to 1 by rho into dou by dou rho into a pi plus 1 by rho into dou by dou pi into a pi plus dou by dou z into az. In spherical coordinate, del dot A equal to 1 by r squared dou by dou r into r squared into ar plus 1 by r sin theta into dou by dou theta into sin theta into a theta plus 1 by r sin theta into dou by dou pi into a pi. You have to remember these formulas which will be useful to solve the problem. We have three types of divergence: positive divergence, negative divergence, zero divergence. In general, the divergence means it's spreading. Now positive divergence. The divergence of a vector field A at a given point P as a measure of how much the field diverge or emanate from that point. Just look this figure at the point P, so it will be spreading. Yes, so this is the positive divergence. Just look the figure B at a point P, it is converging, so it is a negative divergence. This is a zero divergence. What is solenoid? Any vector field which has zero divergence anywhere is called as solenoidal field. The condition for solenoidal is del dot A equal to 0. That means the divergence of a vector is 0. If A is said to be solenoidal vector, then its divergence is 0. Let us take the Cartesian coordinate. The vector A equal to ax into ax plus ay into ay plus az into az. The divergence of this result is 0. Then you can say that the vector is solenoidal vector. Now we will solve the problem. Determine the divergence of this vector field P equal to x squared yz ax plus xz az, and second is q equal to rho sin pi a rho plus rho squared z a pi plus z cos pi az. T equal to 1 by r squared cos theta ar plus r sin theta cos pi a theta plus r cos theta a pi. Now you just recall the formulas. This problem, first one is the problem belongs to Cartesian coordinate. This second problem is belongs to cylindrical coordinate. This one is belongs to spherical coordinate. Now what is the formula for divergence in Cartesian coordinate. Del dot A equal to dou by dou x into Ax plus dou by dou y into Ay plus dou by dou z into Az. Here instead of the A vector, here the given vector is P. So del dot P equal to dou by dou x into Px plus dou by dou y into Py plus dou by dou z into Pz. Now this is the formula. Now what is this value of Px, Py and Pz? So you just look this. This is the vector P. So this is the Px into Ax plus Py into Ay plus Pz into Az. Here the Px value is given here, that is x squared is z. So there is no y term, therefore here no y term, therefore y Py equal to 0. What is the z Pz? Pz is xz. Just substitute this value xz. Now you want to differentiate with respect to x for here, differentiate y here, differentiate z here. Now if I am differentiating this, what is this value? Y and z you can take it out. So you have only the term s squared and the differentiation is 2x. Now it become 2xyz. Coming to y, the value is 0. Coming to z, so x is take it out, remaining is z. So differentiation with respect to z which is equal to 1. Therefore del dot p equal to 2xyz plus x. So this is the final result. Now we'll take the second one. So this is the given problem. Now del dot q equal to 1 by rho into rho by dou rho into q rho plus 1 by rho into dou pi into q pi plus dou by dou z into q z. Now what is a q rho value? The first value, this is a q rho value, this is a q pi value, this is a q z value. Just substitute as such here. Okay. Now you want to differentiate. So you can keep sin pi as such. For rho squared, the differentiation is 2 rho. So already here is one rho is there. So rho is going to get cancelled. The final result is only 2. So here is no pi term. So this value is become 0. Now coming to here, you can take cos pi outside. So remaining is z. The differentiation with respect to z is 1. Therefore cos pi. Now del dot q equal to 2 sin pi plus cos pi. Next, in spherical coordinate, here the vector is t vector. So what is the formulas? Del dot t equal to 1 by r squared dou by dou r into r squared tr plus 1 by r sin theta dou by dou theta into d theta into sin theta plus 1 by r into sin theta dou by dou pi into t pi. Now which is a tr, which is a t theta, which is a t pi? Just go to here, just this value is the tr, this value is t theta and this value is t pi. Okay, just substitute it. Now you want to differentiate with respect to r, theta and pi. So here there is no r term, so this term become 0. Coming to here, you want to differentiate with respect to theta, so you can take r cos pi outside. So remaining is only sin square theta, this value. So what is the differentiation for this? 2 sin theta cos theta. Yes. Now coming to here, here no pi term, therefore value is 0. Simplify this expression and verify this result. Got it? Now we move to curl. The curl of A is an axial or rotational vector whose magnitude is the maximum circulation of A per unit area as the area leads to 0 and whose direction is the normal direction of the area when the area is oriented as to make the circulation maximum. Curl A equal to del cross A equal to limit delta s tends to 0 limit delta s tends to 0 closed line integral a into dl divided by delta s into an. The area delta s is bounded by the curve L and an is the unit vector normal to the surface. This is the curl formulas in different coordinate. In Cartesian coordinate, del cross A equal to ax, ay, az, dou by dou x, dou by dou y, dou by dou z, ax, ay, az. How to remember that? The first row is the directions. Second row is the this del value. Third row is the that is magnitude of the vector. Just look all the formulas, it will be like that only. So you have to remember these formulas, then only you can solve the problem. Just read this formula. Next, irrotational vector. Any vector field which has zero curl anywhere is called irrotational vector. A vector A is said to be irrotational vector, then its curl is 0. For example, just consider the vector A in Cartesian coordinate. A equal to ax into ax plus ay into ay plus az into az. Now the del cross A, that is curl A equal to ax ay az dou by dou x dou by dou y dou by dou z ax ay az. This result is 0. Now the condition for irrotational vector is del cross A is 0. Look this two figure, which is a curl, which is not a curl. So this is the curl is rotating, it is not a curl. So this is a irrotational vector. Now determine the curl of this vector. P is equal to x squared yz ax plus xz az. Q equal to rho sin pi rho pi. Q is equal to rho sin pi a pi plus rho squared z a pi plus z cos pi az. T is equal to 1 by r squared cos theta ar plus r sin theta cos pi a theta plus cos theta a pi. Just take the first problem. What is the coordinates of this? It is a Cartesian coordinate. So what is the formula for curl in Cartesian coordinate? This is the formula. Instead of the a vector, here given the p vector. Therefore, del cross p, which is equal to ax ay az dou by dou x dou by dou y dou by dou z px py pz. How to solve this? So you know the matrix determinations. Yes, you are very familiar about how to find the determinant of the matrix. So just take the ax value, just hide this column and this row. What is the final result? Dou bz by dou y minus dou py minus dou z. Yes, so this is the first term. For the second term, it is a minus sign. This column and this row is hidden. So what is the remaining? Dou by dou x into pz minus dou by dou z into px. Yes, now you just take the third element, this az. This column and this row is hidden. What is the remaining? Dou by dou x into py minus dou by dou y into px into az. Now you know the value of px, py, pz. Just substitute it here now. Yes. Now what is the pz value? X into z. Is there any y term? No. So the result is 0. Now come to py term. So py term is given in the problem? No. So this result is also 0. Now come to px term. What is the px value? X squared y z. You want to differentiate with respect to z. So you can take x square y in out. So what is the remaining? Z. So differentiation with respect to z is 1. Therefore x squared y. Now pz. What is the pz? Xz. Differentiation with respect to x. So what is the value you are going to get? Z. Now what is the py term? It is 0. What is px term? S squared yz. Differentiation with respect to y. What is the final result? X squared z. Now you are getting this answer. Okay. Similarly, you can solve the problem in cylindrical coordinate and spherical coordinate. So about this problem we will discuss in tutorial hour. Now coming to the gradient of a scalar field V is a vector that represents both magnitude and direction of the maximum space rate of increase V. Now the formula for gradient in different coordinates are: for Cartesian coordinate, del dot V equal to dou V by dou x into Ax vector plus dou V by dou y into Ay vector plus dou V by dou z into Az vector. In cylindrical coordinate, del dot V equal to dou V by dou rho into A rho vector plus 1 by rho dou V by dou pi into A pi vector plus dou V by dou z into Az vector. In spherical coordinate, del dot V equal to dou V by dou r into AR vector plus 1 by r into dou V by dou theta into A theta vector plus 1 by r sin theta dou V by dou pi into A pi vector. Find the gradient of the following scalar field. So V equal to e power minus z sin 2x cos hy. Second, u equal to rho squared z cos 2 pi. Third, w equal to 10r sin square theta cos pi. Now look, this v, u, w, these are all the scalar quantity. After applying the gradient, you are going to get the vector. Now just take the first problem. It is a Cartesian coordinate. So now take the first problem. The problem is belongs to Cartesian coordinate. You know the formula for gradient. Del V equal to dou V by dou x into Ax plus dou V by dou y into Ay plus dou V by dou z into Az. Now you just substitute this V value here. Okay, just substitute it. Yes, substituted. Yes. Now you want to differentiate the V with respect to x here. So just differentiate with respect to s here. So this Ez term and the cos y term you can take it out. What is this value? Sin 2x. What is the differentiation for sin 2x? So sin 2x is cos 2x. For this 2x you are going to get 2. Therefore 2 cos 2x. That is this differentiation for this term. Now take this term. Here you want to differentiate with respect to y. So you can take e power minus z and sin 2x in outside. So what is the differentiation for cos hy, which is equal to sin hy? Just substitute. Take the third term. So what is the common term for third term? You just take x term and y term outside. So this is a term you are taking out. You have only z term. Z term is e power minus z. E power minus z. The differentiation for e power minus z is minus of e power minus z, this term. Now you are getting this answer. Likewise, you want to proceed for this cylindrical and spherical coordinate and verify this result. If you have any doubt about this, we will discuss in the tutorial R. Now this is the vector identities. You have to remember this vector identity. It will be helpful for to solve the problem in 5th unit, and also it will help you to derive the expression in 5th unit. The vector identities: del cross A equal to del dot A minus del squared A. The same thing can be written in like this: curl of curl of A equal to gradient of divergence of A minus del squared A. Del cross del V equal to 0. That means curl of gradient V is 0. Next, divergence of del dot del cross A equal to 0. That means divergence of curl is 0. Thank you.